So, we got 2 warm-up problems to do today. The first one we'll do together. The second one you will do by yourself. So if we are on the unit circle, that's key. If we are on the unit circle, what is the sine of any angle in terms of x or y? Y. Sine is y? Agree? Sine is y. Whoa, hey now. Sine is y. Cosine. What is the cosine of that angle? X. What is the tangent? Y over x. Cotangent. X over y. It's just the reciprocal of tangent. Cosecant. 1 over y. Do we agree with 1 over y? Yeah? Because everything needs a co. Okay, so it's 1 over sine, or so 1 over y. Secant. 1 over x. While we're at it, what is the equation of the unit circle?
Equals 1.
Equals 1. Yep. Okay. Okay. Good. So with that being said, you tell me if that point is on the unit circle without using a calculator. I gave you the squares right up there. Okay. And if it is, wink, wink, nudge, nudge, what the 6 trig values of it are. So to prove that it's on the unit circle, it's got to satisfy the unit circle's equation. X squared plus y squared is equal to 1. So that's going to be negative 7/25.
Okay, it's squared.
Ladies and gentlemen. Ladies and gentlemen. Thank you. Negative 7/25 squared is 49 over 625. 24/25 squared is 576 over 625. Those two added together get me 625 over 625. That is equal to 1. So therefore, it is on the unit circle. We have just proven such. So therefore, now we can say with certainty that the cosine of my angle T is going to be the x value, negative 7/25. The sine is going to be my y value, 24/25. The secant is going to be the reciprocal of the cosine, which would be negative 25/7. The cosecant would be the reciprocal of the sine, 25/24. I'm listening. The tangent is going to be sine over cosine, or y over x, which is going to be negative 24 over 7. Which means then that the cotangent is going to be negative 7 24. Those are your 6 trig values. Yes? Okay. So, just based on yesterday, okay, let's recreate our unit circle. Okay? Sure. Good practice. Straight out there. Now remember, next Tuesday, you're going to need 4 values for each spot on the unit circle. 2 coordinates, radians, and degrees. There's an X and a Y for each one. Very good. Okay? Straight out to the right. Let's start there. 1, 0.
It's not even that bad.
I'm listening.
Do you also want us to include that it could be 360 degrees?
In terms of next week, Tuesday, no. You don't have
Could be
to.
extra credit.
No.
Could you swap them out?
No.
Okay.
Okay?
Do we need all 3 terms for?
Yep. Just send that. Next one up is what? 30 degrees. Pi over 6 radians. No, we gotta get the coordinates first.
Square root of 3 over 2.
Comma half?
Yeah.
Okay. Next one up is 45. Pi over 4. Coordinates. With 2 over 2, both of them. Next one up is coordinates. Then we got straight up. 90 degrees. Coordinates. Now, if you're smart, that's what you memorize. Because everything else is just those. So now you come back over here. Right? So in terms of coordinates, this one would be negative 1/2 square root of 3 over 2. This one would be negative square root of 2 over 2, negative square root of 2 over 2. This one would be, oops, I'm sorry. Yep, that should have been positive. This one would be negative square root 3 over 2, 1/2. 30-degree gap, right? So this one is 120, 2 pi over 3. This one is 135, or 3 pi over 4. 150, 5 pi over 6. Straight out. Then you got 3 down here. And you got 3 over there. So this one would be square root 3 over 2, negative 1/2. Square root 2 over 2. Now you just got to fill in radians and degrees, right? Okay, 30 more than 180. 210. 7 pi over 6. 45 more than 180. Or 15 more than that. 15 more than that. Or 4 pi over 3. Which one? Yep. Right? What do we do that in? What?
7.
Maybe 7? And that would be waiting on questions? So 5 minutes is very doable.
It's just like.
Will the 5 minutes include the co-tangent of every?
How hard is that though? That's 30 seconds
Or
if
it takes
that.
time to write stuff down. Like,
No, it doesn't.
It's not thinking time. Writing stuff.
I know.
I know. And like,
You got plenty of time.
5 minutes.
You have plenty of time, Louis. I hate to break it to you.
Wait, are we
It's
being
like I
timed?
know this stuff
You get
already.
it 5 minutes.
I'm
What
not-
if we don't finish it in 5 minutes?
Then you turn it in.
Okay.
Yeah. All right.
That's what you have to remember.
So that's what we need. This is basically the quiz. I'll wait till everybody's done. I don't want to interrupt anybody's conversation. I'm just busy up here teaching. The quiz on Tuesday will look exactly like this, except all of the numbers are going to be gone. And you have to fill them in. The parentheses will be there, the commas will be there. Okay? I think even the degree symbols are there. I don't remember if the degree symbols are there or not. Okay? You just have to fill in the numbers. Again, 5 minutes. Takes you more than that, you need to study more. Okay? All the way through, all the way around. So today now, you can use either one of your unit circles, the one that we just made or the one that you made yesterday. Okay? We are going to be interpreting the unit circle today. Okay? Which means I'm going to say something like, what is the sign at pi over 6? So you go to pi over 6 on your unit circle, and you find the sign. Sign is X or Y?
Y.
Sign is Y, so the sign at pi over 6 would be 1/2. We went to pi over 6 on our unit circle, which is right here, right? And we went to the sign value, which is the Y value of the coordinates of that particular point. So that's this one, X comma 1. 11 pi over 6, the sign of 11 pi over 6. Negative 1/2, do we agree? Yes? Okay, go to 11 pi over 6. So we're going all the way around the circle to here. Sign is Y, negative 1/2. You find me those two. Side note, don't let me forget to say that if you have any Huff and Gaspers that need to be turned in, today is the last day for Huff and Gasper. Okay? Alright? Okay? Cosine at pi over 4. Fun square root of 2. Hold on, we have way too many side conversations going on at a loud volume. Your guess?
Negative square root
And yours? One is right, one is wrong.
2. Are we doing number 3?
No, we're currently doing number 3.
Oh, number 3. Sorry, I thought we were doing number 4.
Okay.
But yes.
Square root of 2 over 2. Okay, go to pi over 4. Get the x part. It's the square root 2 over 2. Cosine at 5 pi over 4.
Negative square root.
Agree? Okay. Try those two. Ooh.
I think
Cotangent at 3 pi over 2. Just 0? Because it's x over y, right? So that's 0. Okay. Cosecant at 3 pi over 4.
it's 2 square roots of
2 square roots of 2. Any takers to an agree?
So it's 1.
So that's a no?
No. Well, it's 1. No, it's
Okay.
Square root of 2.
What do we got?
Square root of 2.
Square root of 2. Any takers on square root of 2? Is that what, Vincenzo, you're going to square root of 2?
Yeah.
2 extra takers on square root of 2? Alright, so let's talk about this one. So it's 1 over the sine at 3 pi over 4. The sine at 3 pi over 4 is the square root of 2 over 2. Keep, change, flip. Right? If you're sitting at the horseshoe table, you should have gotten this one right off the start. Right there. Okay? Right? Which then becomes 2 square roots of 2 over 2, and the 2's cancel each other out, leaving you just with the square root of 2. Keep, change, flip. All right, here we go. Here's the challenge. Challenge.
I need like some group therapy about
So what's the cosine of pi over 3?
1/2 squared.
1/2, right?
Yeah.
So that means that this then is 1/2 squared. Right? What's 1/2 squared? 1/4. Secant at 5 pi over 6. Secant is what? 1 over x, right? Okay. 5 pi over 6, so that's the reciprocal of the x value at 5 pi over 6. That'd be -2 over the square root of 3. Yes?
Yeah.
So this is -2 over the square root of 3 squared. What is that squared? 4 over 3.
You reciprocated it and then put it.
Oh,
Yeah.
Cosecant
Okay.
at 7 pi over 6
you know what? I'm not going.
would be what? 2 over -1 or just -2. So if I'm going to combine them, what do we have to do? Common denominators. Common denominator is going to be 12. First one, 3. Second one, 16. Third one, 48. 3 plus 16 is 19. Minus 48 is -29. 4 times 12 is 48.